Hi, this is a lesson on finding all of the zeros or the roots of a polynomial. This is talking about if a is 0, then x minus a is a factor. If x minus a is a factor, then a is 0. All that is saying is what we learned from quadratics, that if I have a factor that looks like x minus 3, and this is a factor, then positive 3 would be considered a root. Also realize that we call them solutions, zeros, or x-intercepts, right? Another thing that's very important for us to remember, oh yes, and the degree. The largest exponent, like we spoke about last class, tells us how many solutions exist. Now, it can be a combination of real or imaginary. We'll talk about that. Irrational, remember this is talking about any answer that has a radical as its part. So we've had answers that look like 3 plus or minus 2 square root of 5. This would be called irrational. Or imaginary, anything where we have a negative inside of a radical, for example, negative 4, this would convert, as we remember, to the letter I and 2. These answers always come in pairs called conjugates. A conjugate is where you have the identical expressions. So let's say we have 3 plus 2 square root of 5. This is the plus version. The opposite answer, or the alternate answer, the paired answer, I should say, is 3 minus the square root of 5. This should be familiar because we remember writing 3 plus or minus the square root, 2 square root 5. That's all of this is saying. If you have something like 7i, this is an imaginary answer. These always come in pairs. The conjugate would be the opposite of this, so the conjugate would be negative 7i. So then we could write it as a single statement, plus or minus 7i. This would be the pair of imaginary answers. This would be the pair of irrational answers. Many times you might see something like this, looking like 2 plus, 3i. This would be 2 plus or minus 3i. This would be the pair of answers. They always come in pairs. So, if we have, what we are told here is to write equations for f of x given the following roots and equations. Your equation should be in standard form with integers and coefficients of least degree. What this means is we want to write a function. Maybe we call it f of x. And we want it to be in ax cubed perhaps, plus bx squared, plus cx plus d. We want the powers to be descending, and we want the terms to be in order. It kind of means the same thing. So from before, we know that if this is a root, this particular factor would be x minus 3. This factor would be x plus 2. This factor would be x minus 1. My job now, and I'm going to cover this so we can see the work that we need to do. No, that didn't work. My job now would be to multiply that out so that I actually have a form that was in standard form. So first what we would have to do is we would have to FOIL out two of these pieces. So x times x is going to give me x squared. X times 2 is going to give me plus 2x. This part will give me a negative 3x. This here will give me negative 6. These two terms are common, so I will then combine them, giving myself a negative x with a 6 in the back and x squared. Now we must remember also that we still have this last term which we've not yet used, so we will multiply with this. You can put it in the front or you can put it in the back. It really doesn't matter. Then we will continue to multiply. Now as I do this distribution, I'm going to list my first set of answers in this line and my second set of answers underneath. Watch. This is going to give us an x cubed. This multiplication piece is going to give us a negative x squared. This piece of multiplication is going to give us negative 6x. What I'm next going to do, I'm going to use a different line to record these parts. This is going to give me a negative x squared. I notice that I've got x squared terms in this column, so I'm going to stack it right beneath that. So I'm going to do my first multiplication here, be negative x squared. This multiplication is going to give me a positive x. Again, I'm matching up my like terms so that I can just have columns of like terms. Finally, this piece is going to give me a positive 6. What I do now is I will simply combine the like terms. Remember what we're trying to do. We're trying to take the individual roots, the 3, the negative 2, and the 1, turn them into factors, and then multiply them out so that we can find the standard form polynomial. So, combining my like terms in these columns, this will give us x cubed. This will give us negative 2x squared. Notice that the exponent did not change when I did my addition. This is going to give me a negative 5x. This will simply give me 6. Here, let's call it f of x. This would be the final polynomial that had roots of 3, negative 2, and positive 1. In like manner, on this right-hand side, I would do the exact same thing. All right? So, this time the roots are negative 1/3. The root would create a factor of 3x plus 1. The 4 is simply going to create x minus 4. This 1/2 would create for us 2x minus 1. We would follow the same principle. We would FOIL out the first two, we would create our trinomial, and then we would multiply the last binomial as we did in the first example. So what I did is I took a moment and simply multiplied it out, and you can see that I first FOILed these two, or double distribution, combined my like terms, the negative 8x and the negative x, to make negative 9x. Here it looks kind of close. Then I brought down the last binomial, multiplied. Now again, I did the same thing as before. My first set of distribution, but I used the black ink. I multiplied these three answers here and got these three pieces here. In the second line, in the blue line, I multiplied underneath, doesn't matter top or bottom, I just tend to do it this way, and I got these three answers here. Notice how they're stacked so that in these columns you have like terms, and I should have probably organized this 6x cubed to be underneath to make it a little more clear. This is here, this next term, the 27 and the 2 will combine to make a negative 25x squared, and then just following the columns on down. So, what I'm going to do now is we need to compare when we have imaginary answers compared to real answers, or if we have irrational answers compared to real answers. The real answers The integer answers, the 3, the -2, and the 1, are very simple to do, as are the half, the 4, and the 1/3. We just did examples of these here. They turn into factors, straightforward binomials, and they're only 1 per root. However, what we have to remember is that when we are dealing with imaginary answers, we have to remember that these pieces always come in pairs. We have to remember this. So I'm kind of just rearranging this page so as to allow for us to see this. All right. So irrational and imaginary solutions always come in pairs, or called conjugates. Remember, the conjugates are the same thing. So for example, if I have 3 plus 2 root 7, the conjugate would be 3 minus 2 square root 7, and I could write it as 3 plus or minus 2 square root 7. This would be both conjugates in one statement. We've seen this at the end of the quadratic formula, and we've seen it when we have completed the square. What this video is going to do, we're going to work these examples, and then I'll end this particular video. I don't want this to get too long. The second video, we'll talk about finding all of the roots. There's going to be a second video here. Let's look first at example number 5, or example C. This is a real rational answer. So this will simply come out as a factor of x minus 5. The second here is going to be an imaginary answer. Again, it comes in a pair called a conjugate. So I am missing one of them. This is the positive I. I also need the negative 2i. And this can be written as plus or minus 2i. I'm going to use this to complete and write the polynomial function. Now, in blue, I already have the rational factor here, the one that produces the rational solution. I need to now use red, this red quantity, and create the 2 irrationals into a single expression. We're going to do something called uncomplete the square. I want to watch this carefully and explain it carefully. So, these two parts, we're going to write them as plus or minus 2i. We will set it equal to x. This should look slightly familiar, maybe, from the quadratic formula, or even from completing the square. We're going to uncomplete the square. So, in this particular case, what I'm going to do is I'm going to realize that this expression here is the same as saying negative 1 inside of a square root. Now, if I want to get rid of a square root, we know that we would have to square. This is the first. I will square both sides. What I am left with now is x squared to be equal to, this becomes 4. This simply becomes negative 1, and they will multiply to one another. I now have x squared is equal to negative 4. What follows is x squared plus 4 is equal to 0. This, when I have finally made it equal to 0, is the other factor. This and this will multiply to create our new polynomial. So I will bring this here. I ran out of space. I want you to be able to see the entire problem. I will bring this part here, and we will multiply. So, to reiterate, the 5 creates a rational factor, which then is simply x minus 5. The imaginary answer has a partner, or a conjugate, which then creates for us plus or minus 2i. I set that equal to 0. I get rid of the radical by squaring both sides. I end up with x squared to equal 4 times a negative 1, which creates negative 4. I make it equal to 0, or I solve for 0, creating a binomial of x squared plus 4. That is the factor produced from the imaginary answers. I then take these two and I multiply them together. X cubed plus 4x minus 5x squared minus 20. Now this is not in standard form because I see that the exponents are out of order, so I'm going to rearrange as x cubed minus 5x squared plus 4x minus 20. This would be the polynomial degree of 3 that had solutions at 5 and 2i. And in fact, this one would have solutions at 5, 2i, and negative 2i. I'm going to do one more, and then I'm going to pause this video, end this video, and pick up a second video. So, looking at example D, we have again a rational root. This whole number, this integer, simply would produce x minus 3. This is one of the factors. What I do see in red, I see one irrational root. I have to remember that they always come in conjugate pairs, so I understand that this one is going to be 1 plus or minus the square root of 5. The pair of with the 1 minus 5 would be 1 plus the square root of 5. I take this and I set it equal to x. Again, I'm going to follow a process called uncomplete the square. This will be added to this side here. So I will have x minus 1 to be equal to plus or minus the square root of 5. I now have a square root by itself. I am going to square this to get rid of the radical. I don't want there to be a radical. Squaring this side also requires me to square this side here. This will produce just the number 5. On this side, what I really have is x minus 1 times x minus 1. If we factor this out, we will end up with x squared minus 1x minus 1x. That's really kind of small. Five is here. X squared minus 1x minus 1x plus 2. Or plus 1, sorry, plus 1. Foiling that out. These are two alike terms. I will have negative 2x plus 1 is equal to 5. I need this to be equal to 0, so I will minus the 5 minus 5, which will produce for us x squared minus 2x minus 4 to be equal to 0. This is the other factor, combining with this factor, and I will have this. I'm going to pause this. I'm not going to do this one now. I'm going to bring all of the parts here. X squared minus 2x minus 4. That's the factor derived from the irrationals. I'm going to bring this one over, multiply here, x minus 3. Looks like k minus 3, sorry. And I'm going to multiply these. Again, because I'm multiplying a binomial times a trinomial, I'm going to use the two-line process where I multiply this first set here. This is going to give me x cubed. This will give me negative 2x. This will give me negative, sorry, that's 2x squared, negative 4x. And underneath in blue, This is going to give me negative 3x squared. This part will give me positive 6x last. This will give me positive 12. Notice again, if I combine it this way, I've got vertical columns that have like terms. What I will do is combine my like terms and I will have my final polynomial. Negative 2 minus 3 gives me negative 5x squared. Negative 4 plus 6x gives me 2x plus 12. And I'm going to call this f of x. This is the polynomial that would have these as 2 out of the 3 solutions. This is the end of this video. I'm going to pick up another video, perhaps finish this one, but I definitely have another lesson to talk about in terms of finding all of the roots. Thanks.